MGIIT is actually collaboration policy between government, okay, G to G, and we try our best to collaborate with Japanese organization that try to introduce Japanese style engineering education system. And we have a lot of program, undergraduate program. We have mechanical, chemical, and also electronic undergraduate program that we have Japanese lecturers and also research center. This is some short video, okay, regarding with MGIT. Okay, so there's a very quick introduction regarding with our entity, which known as MJIIT lah, under University Technology Malaysia. So to have a what do you call a quick introduction regarding me myself as what do you call promoter for TRIS what do you call program. I think some of you are somehow familiar with this word TRIS. I will explain later in a very brief what do you call slide. Okay, I think previously there is Dr. Oleg, I think from what do you call a Samsung consultant that also champion in this so-called TRIS, MATRIS, International TRIS Association. So he is the president currently, a president for International TRIS Association. So me just what do you call Malaysian what do you call person who really passionate about TRIS. So my first engagement with what do you call national level is be a part of economic transformation program under what do you call Prime Minister department, Ministry of Prime Minister. So we have what do you call promoted TRIS as a part of the tool that try to what do you call change what do you call my the perspective of new tools, trees innovation tool, a part of Malaysia transformation initiative. Okay, so this is my first role in 2014 to introduce trees in the national level. And then, okay, so for some of you not familiar talking about the word trees, so trees is an acronym coming from Russia, okay? It's not coming from Malaysia, it's coming from Russia. So here it is how it sounds. Teoria Resenya Izrobetatylskik Zadach, okay? So that is the acronym of trees. Okay, so the in English is represented by theory of inventive problem solving. Okay, in Malay we call it teori penyelesaian masalah inventif. So you will heard trees here and there, and it will what they call represent the acronym. The Russian acronym stands for Teoria Resenya Izobetatilskik Zadach. Okay, so maybe you can Google or you can try to pronounce it by yourself. Okay, so trees is being created by Genrit Solvik Altschuler. Okay, so he is from Baku, Azerbaijan, and he is actually a science fiction book writer initially, and he will been what you call being invited to support military movement initiative under World War II, and he is good in what you call in doing analyzing things, especially science and technology, and he been assigned to look into technology coming from the military patent database. Okay, so from there he look into this kind of development by the engineers and so on and so forth, and they try to improve how the technology can be contribute into this military war race. Okay, so from the beginning he tried to look into how to develop a solution in solving engineering problem faster and better for the engineers at that time. Okay, so during his what you call study, okay, he came out with this kind of theory. So there is a three main element coming from the three theory of inventive problem solving. So the first part is problem and solution are always repeating across industry. Okay, so at that time he is focusing on military industry. Okay, so how does the design of aeroplane somehow repeating in terms of engineering problem to develop a submarine, to develop a aeroplane, to develop a tank, or to develop what you call military helmet. Okay, so the engineering problem is they try to develop a bulletproof shield, but it costs heavy weight regarding with the product. Okay, so how to solve this kind of bulletproof safety kind of needs and doesn't imply or have any issue regarding with the weight. Okay, so the problem repeating across the product design, engineering problem, concept, and so on and so forth. Okay, number two, he identified that pattern of technical evolution also repeated. Okay, so here I show a very simple image of television. So television using the tube kind of technology, and nowadays is LCD screen. The thickness is improved, and the quality of the picture also improved. Okay, so during 1990, we doesn't expect that the tube TV can be transformed into a thin LCD screen. Okay, so there is two type of mindset, the customer mindset and also the inventor mindset. Okay, so for the customer mindset, they doesn't care much what next happening into a certain technology, but for the inventor or manufacturer or designer, they really have to focus, have a foresight, and how to go beyond 5 years or 10 years ahead with the new technology coming into the market. Okay, so this is how actually trees able to predict what happened next. Okay, so this is the second part of trees. The third part of trees is actually try to develop a new innovative solution outside your box. Okay, so I'm a mechanical engineer. So how do I want I want to learn a new solution coming from chemical engineering that able to resolve my problem, engineering problem, could be faster, better, and cheaper. Okay, so I need to go outside my mechanical engineering domain of knowledge or expertise and try to find a better solution from chemical engineering. Okay, so these are the things that trees able to help engineers to speed up, to expedite the process of innovation and development of new ideas. Okay. So Altshuler studied about 200,000 pattern, okay, and then he found out there's a 1,500 he called technical contradiction, okay, technical contradiction. So so-called technical contradiction is actually the engineering problem that is complex and high value, okay, for us to um, solve it and create more value coming from this new technology or new kind of application. Okay, so engineering problem, technical problem are being challenged by Altshuler, where he give this kind of statement. You can wait 100 years for enlightenment, or you can solve problem with 15 minutes with this principle, a trees principle. Okay, so this kind of challenges are being given by Altshuler to all engineers in all over the world. Okay, so it is he challenged the way how engineers solve problem. Okay, and it just take 15 minutes by using trees to what you call go outside the box, learn what happened in the future, and try to solve problem within 50 minutes. Okay, so without trees, okay, I've experienced this by myself during my terms in automotive industry. Is our engineers doesn't have any proper tool, structured tool beside quality tool. Okay, we have Kaizen, we have Six Sigma, we have design for Six Sigma, we have a lot of